In this video, we have discussed complete analysis regarding autocorrelation and its use in identifying time series components. But don't skip the theory part and just jump onto the software usage part. The theory is also equally important. Hence, watch the video till the end. This is the second video of the series Business Forecasting, and in this video we are trying to explore various data patterns. So before that we want to discuss four important criteria about usefulness of the data, and we already have discussed this in the previous video, but this time we just want to elaborate this little more. So first of all, the data should be reliable and accurate. That means the data should be collected from a reliable source and with proper attention. And then the second point is the data should be relevant. By relevant, we mean that the data should be representative of the circumstances for which they are being used or collected. Thirdly, the data should be consistent. Consistent means that data definition should not change in between the series of data collection. So one example is for you can consider the cost of living index number. So if you check the cost of living index number definition, then it is decided based on a particular basket of goods that the government decides. But if the items considered in that basket of goods changes, then the value of CLIN, cost of living index number, will also change. So therefore the definition itself changes. So therefore, if you are considering a data set of data for CLIN, then in that case you make sure that for all those data points the same basket has been used. Similarly, you can take another example of share price. For any share price, suppose you have a share split. What happens in a share split? In case of a share split, one share is divided into two, so the number of shares becomes double, but the total value of share remains the same. So if share split happens, then there is no point in monitoring the share price. So for example, if you are taking 30 days of share price data, but in between those 30 days there is an occurrence of share split, then there is no point in monitoring that data. So the main point is, when you are considering particular time horizon for data, then the definition of the data within that time horizon should not change. And finally, the timeliness of the data is also important. This means that the data should be collected, summarized and published on a timely basis in order to make sure that it is carrying a greater value in the analysis of or forecasting. So these are the four important criteria need to be maintained for the usefulness of any data. So now let us come to the types of data. There are mainly two types of data. One is your time series data, another one is cross-sectional data. And if you check the differences between these, there are mainly two broad differences. One is the very basic definition of time series and cross-sectional data, that is, the time series data is collected with passing time, normally at a constant interval. That means you have a time, for example, you are collecting a data every day. So day is your time, and along with the timeline you are collecting the data. But what happens for cross-sectional data? For cross-sectional data, it is collected at a particular point in time. So that means if it is a daily data, you are not collecting that cross-sectional data daily. I mean, you may be collecting that, but your analysis or the data itself is on a particular day. So this is the first difference. What is the second difference? Second difference is, in case of time series data, normally you are interested in only one subject, but in case of cross-sectional data, there can be more than one subject. And now what is more than one subject, what is one subject, we will discuss in a while in the next slide. So for example, you can see this particular data. So temperature of a certain workplace, or say some factory or some job shop, the temperature of that shop has been collected every day at a particular time, 10 a.m. say. So you can see every day at the same point of time a single reading has been taken and the data is flowing with time. So this type of data is called the time series data. But suppose on a particular day, say day number 10, the decision maker has taken 5 temperature readings and he thinks that the temperature is a function of number of persons staying in the room. So at different points in that day, when 2 persons are there, 5 persons are there, 1 person is there, 4 persons are there, 6 persons are there, he has noted down the temperature value of that particular room on that particular day. So you see this type of data, the data is not varying with time or not flowing with time. It is collected on a particular day. So it is not a time series data, it will be a cross-sectional data. So this type of data will be a time series data and this type of data will be a cross-sectional data. Now in the earlier slide we have told you that the cross-sectional data may have more than one subject. You can see clearly there are 2 subjects here. One is temperature, another is number of person. But for time series only temperature is there. So in case of time series, generally when we are analyzing a data, only one subject is there. But for cross-sectional data, there can be more than one subject. Here it is 2 subjects. Sometimes it can be more than one subjects also. So for example, if you are considering the temperature variable with respect to the number of persons that are observed in the workplace, but there can be a third variable also, maybe pressure. There can be a fourth variable also, maybe lighting, and so on. So this is the cross-sectional data and this is the time series data. This is the main difference. Now let us come to the time series data. The time series data can be defined as a combination of 4 primary components of the data. The first component is trend. Now what is a trend? Trend is a long-term growth or decline in the data. So for example, in a data, if you see this type of behavior over a period of time, this is your time axis and this is your data. So if you see that this type of behavior is observed in that data, that means you are observing a positive trend. It is also possible that the data is like this. So in that case we will say that it is a negatively trending data. It is also possible that the data is like this. Then we will say this data is not having any trend and this is a stationary data. So important is here, for any data where trend is not available, no trend is there, it is called a stationary data. Stationary series. Okay, so if you have understood the trend, then let us come to the next component of data, time series data, which is the cyclicality. For cyclicality, the trend will be there, but the actual data will be sometimes more than the trend, sometimes less than the trend, and so on. This will go on like this. And the distance between 2 peaks or 2 similar points will be, if you take this distance, this distance, or say this distance, this will be generally more than 1 year, greater than 1 year. This is the definition of cyclicality. But in general, for cyclical fluctuation, this time gap, this particular time gap is generally more than 2 years also, more than 2 years, or sometimes 5 years, and sometimes 10 years also. So what I mean to say is, if you have seen one peak here, then it is expected that the next peak will come in either 2 years or 5 years or 10 years here. So that is called a cyclical fluctuation. Now you can understand from here that if you are only considering 1 year time frame or time horizon, then cyclicality may not be a big concern for you, because you see, suppose this is 10 year, this is 10 year gap, and you divide it by 1 by 10, so this is only 1 year. So you will see that this much of data will not have any particular cyclical component available here other than trend. So the influence of cyclicality will not be very clear in 1 year time horizon, and therefore when in most of the cases we will deal with 1 year data or 1 year forecast, and therefore the influence of cyclicality will not be very much prominent in our analysis. So in most of the cases we will omit any kind of cyclical fluctuation, because that will not be our concern in any case. Okay, so the next part is seasonality. Seasonality is the variation in data over a period of time, and the nature of the fluctuation will repeat itself after 1 year. So for example, you can see this is one part of data, this is the another part of data, and this is the third part of data, and the nature of the fluctuations are repeating itself after a certain period of time. And in case of seasonality, this is generally 1 year. So if you take two peaks or two similar data points, then the gap between them will be 1 year. So for example, if you have a quarterly data, then within 1 year there will be 4 seasons, or those seasons are the 4 quarters. And if you have a monthly data and your data is varying every month, then in 1 year you will have 12 seasons, because you have 12 months in a year. So like that, seasonality will be decided. And what is irregular variation? If you take out all these three components, like if you take out trend, cyclicality and seasonality from the time series data, then what remains is the irregular variation. You cannot draw it in any case, because it is not in your control, it is uncontrolled. You can say it is an error or unrecognized, because you cannot process, you have not any idea or any kind of processing power or capability to understand what is going on beyond these three: trend, cyclicality and seasonality. And therefore it is a big question mark for you, and it is the irregular variation. So basic point is here, if you take trend, cyclicality, seasonality out of the total data, which is your original time series data, then what remains there is the irregular variation. Okay, so now let us think a little practically. So how will you identify the trend, seasonality or cyclicality? So let us forget about cyclicality for the time being, because we are dealing with 1 year data mostly. So cyclicality is not a concern now. So let us talk only about trend and seasonality. So for example, now I have given you 3 types of time series data. This is one, this is second, and this is the third one. Now if suppose I ask you that, can you tell me in these graphs whether you find trend or seasonality, then looking at the first graph, you will tell me this, yes, it obviously some kind of trend is there, because I see that the data is moving up in this way towards upside. So trend is of course present here. Seasonality is also present here very clearly, because the nature of the time series is repeating itself after a certain period of time. So see, this is 1 2 3 4, then again 1 2 3 4, then again 1 2 3 and 4. So 3 and 3 are similar, 2 and 2 are similar, 4 and 4 are similar. In this way, that nature of the series is repeating itself within 1 year. So this was for 2011, then the next one is for 2012, and the next one is for 2013, and so on. So just by looking at this graph, anyone can tell you that trend and seasonality are present. But unfortunately, this type of graph you can only expect in either in examination question or in books, where they are trying to explain something and making things easy for you. But in all practical situations or practical purposes, the clarity will not be there in this manner. Like trend and seasonality may not be very apparently visible in those cases. So for example, you take this example here. Can you see any seasonality? Of course you can see. The seasonality is very clearly visible here. In every year, the same fluctuation, similar type of fluctuations are observable very clearly. But do you find any trend here? It is difficult to say, because first of all, you see it is like as if it was increasing, then now it is decreasing. Maybe it is actually constant. You cannot say anything specific. So seasonality, yes, it is present. Trend, we don't know, not sure. Now come to the third one. Trend, not sure. Seems it is not present, it is flat, but at the end of the data it is like moving downwards. So it may be present, may not be present. So trend, don't know. Seasonality, okay, it seems that something is repeating here also, but it may be present or may not be present. It can be totally irregular variation also, because it is not like this one. It is not like it is. You can see that the data is not exactly repeating itself. It is looking like the previous one, but not exactly the same. So it may be seasonality or it may not be seasonality. If it is not seasonality, then it is irregular variation. Then basically what I mean to say is, trend is also not clear, seasonality is also not clear. So what will you do? So in all those cases where trend and seasonality are not clear from the very nature of the graph itself or the time series graph itself, then you use the concept of autocorrelation. Now what is autocorrelation and how to use that in case for identifying trend and seasonality, that we will see in opening an Excel sheet, and from that Excel sheet also we will go to some statistical software, and where we will calculate the autocorrelation and make inferences. So let us come to the Excel sheet. We want to use the Excel sheet only to show the calculation of the autocorrelation, how it is done. Once you understand that the calculation procedure in Excel, then we will not use Excel. We will just shift to the statistical software, and the software will do the calculation for you. So let us come to the Excel sheet first. So this is your Excel sheet. You see, this is a forex data. Forex means foreign exchange. This is euro versus USD foreign exchange value that is noted for the last. These are the days, This is the for last 39 days data is there. So now we will calculate the lag. So first of all we need to learn what is the definition of autocorrelation. So what is autocorrelation? Autocorrelation is the correlation between the data and the lag data. So this is the definition of autocorrelation. Means if you calculate the correlation coefficient between the data and the lagged version of that data, then that correlation coefficient will be called the autocorrelation. Now what is a lag? Lag means, for example, lag 1 is the offset of the original data by 1 unit or 1 row. So for example, if you write B2 means the day 1 data here, that means the data is lagged 1 times. Now if you write the day 1 data here, it means it is lag 2 times lag. Similarly, this is lag 3 and this is lag 4. So now you can copy this to the end. So this becomes your lag data. Various lags are there, lag 1, 2, 3, 4, you can continue. Now I will hide some of the data from here so that you can see the calculation. So I am hiding this. So now you calculate the correlation coefficient. What is the function for that? Excel has given you a function correl. Correl is used for correlation, and if you give the array for the two ranges, for example this range and this range, this gives you the correlation coefficient. This is the correlation coefficient of lag 1. You can calculate for lag 2 also correlation between the original data and lag 2 data. So this is your lag 2 autocorrelation. Similarly, you may want to calculate lag 3 also. So use the correl function. So original data is your array 1 and lag 3 data is your array 2. So this is your autocorrelation for lag 3, and in this way you can calculate lag 4 also, and as many lag as you want until lag 39. But normally lag 10 to 15 is more than sufficient. Now we are not going to calculate this using Excel because it is not useful. So we will use a software. Now the software output, what it will give you is nothing very special. It will give you a bar chart. Well, it will put the lags in the x-axis and the corresponding correlation coefficient as the bars. So for example 0.24, this will be 0.24, then minus 0.19, like this, minus 0.19. In this way it will plot a graph for us, and this graph is also known as correlogram. This is known as correlogram. So now we will use a particular statistical software called SPSS, and this is developed by IBM. So I will open this software and show you how to process this autocorrelation function in the software. So before that I will unhide this data and copy this data from here, because I am going to copy this data from here to SPSS. So this is your SPSS screen. First of all, I am copying the data from Excel. I have already copied that from there. So here I am pasting. So you can easily paste here. Now once you have pasted this, certain operation has to be followed. You see there are two types of entries possible here. One is data view, which is the same as the Excel sheet view, like two columns will be there, but you see the variable names are missing here. So first of all, I need to enter the variable names here. For example, my first variable is day and second one is EURUSD value. And then you should actually adjust the decimal places. For day, the decimal should be 0, and for EURUSD, let it be 5 decimal places. And change the measure also. It should be scale measure. Any variable data like temperature, pressure, weight, currency value, anything variable data, you should always use the scale. This is the ratio type of data. So in SPSS language, it is called scale. So use scale here. So once this is done, then your data is ready. See, the day has been changed to 1, 2, 3, 4. Earlier it was 1.00, 2.00, 3.00 and so on. And EURUSD is also showing 5 decimal places. So now the data is ready. Now we will go to analyze, then forecasting. Okay, so before doing this, we will first plot the data in graphical form, in time series form, and try to see if we can identify visually the trend or seasonality before calculating or generating the autocorrelation report. So for that, you go to graph here. You can do this in Excel also, but I am showing this in SPSS. You go to chart builder here. So we need to develop a line chart, because time series graph is a line chart basically. So select line from here and select this one and drag this here. Once you drag this here, then x-axis and y-axis will be shown blank. So you drag EURUSD from here to y-axis and then day from here to x-axis. Once this is done, you click on OK and it gives you the time series plot like this. Now can you tell me, do you find any trend here? Because I am not finding any trend. It seems that it is a completely stationary data. Maybe some feeble kind of trend is present. And what about seasonality? To me, like only by looking at the data, I can only see some of the irregular variations here. Maybe some seasonality is present, but I cannot detect it visually. So see, this is the perfect example where we should approach towards the autocorrelation part. Otherwise, for data which is very clear about trend and seasonality, we do not need to process any autocorrelation here. But in this case, you see, trend is also not clear, seasonality is also not clear. So in order to make them clear, we need to process autocorrelation. So for that, you go to analyze, then forecasting, then autocorrelations. Then make some little changes. EURUSD should be your variable. So select that and click on here. Click on this particular icon. So it will be included here. Then in option, you should select the Bartlett's approximation. We want the confidence interval to be developed properly, and independence models are not very good. So Bartlett's approximation you should select. And in the number of lakhs, it is normally giving you 16 lakhs by default. Let us make this 20 just to check what happens. So continue, and you do not need to generate the partial autocorrelation, so uncheck that, then click on OK. So this is your autocorrelation graph. So see, this is the lag numbers. This is the first lag, second lag, third lag, up to 20 lags, and these are the correlation values. If you want to show the correlation values, then click on the graph, and if you right click on the graph, it gives you the option of show data levels. If you click that, then automatically these correlation values like correlation coefficient values are also shown here. So this is your autocorrelation graph. Now okay, that is fine, but what is the interpretation of this graph? For the interpretation of this graph, I have noted down the rules here in the notepad. So these are the rules. So let us verify the rules. So what is the first rule? First rule is if any of the autocorrelation values are outside the 95% confidence level. So these two thick lines are the 95% confidence level. So any of the autocorrelation values, like for example, see this 1.461 value is out of this upper confidence limit. So we will directly say that there is a trend. So remember earlier from the graph itself, we were unable to conclude that there was a trend or there was not a trend. So from here clearly we can identify that there is a trend. Then if none of the autocorrelation values is outside the 95% confidence level, so for example here it is outside, but suppose it was not outside, all the values are inside these two thick bands, then what is the conclusion? There is no direct conclusion. Conclusion is you need to go to step 3. So what is step 3? Step 3 is check the LBQ significance values. Now what is that? You see here, this is the table generated and these are the LBQ box Young statistic. You need to consider this significance value, last column. So if the last column values are less than 0.05 or 5%, then there is a trend. That means you are rejecting the null hypothesis that there is no trend, because your significance values or the p-values of the test are less than 0.05. So, but in this case you don't need to worry about this, because in the first step itself you have already seen that one value is outside the confidence interval, and therefore there is a trend. Okay. Now also, if all the values are greater than 0.05, the data is stationary. Obviously, if all these significance values are greater than 0.05, that means you are unable to reject the null hypothesis that there is no trend. So the data will be stationary. The conclusion will be that the data will be stationary. Now what about seasonality? For seasonality, if there is a n period seasonality, then there will be significant autocorrelation value for the nth lag. So for example, here you can see 1, 2, 3, 4, 5, 6. Sixth value is quite significant. Then 1, 2, 3, 4, 5, 6. Again sixth value is little significant. Then again 1, 2, 3, 4, 5, 6. Sixth value is little significant. So it seems that in every sixth value there is a significant autocorrelation, and therefore it may be possible that the data is suffering sixth period seasonality. So remember that it was a daily data of EURUSD forex. So maybe at the end of the week or at the beginning of the week there is a seasonal pattern of the value. So you know that in case of forex, 2 days are closed. Only from Monday to Friday the market is open. So maybe at the end of the Friday or at the beginning of the Monday there may be some seasonal effect that is getting reflected here. So I hope that you have already understood how to identify trend and seasonality using autocorrelation analysis. In the slide we have written down these steps. in a formal way, you can read that and understand it in a better way, or you can consider the points written in the notepad also that I have shown you while calculating the autocorrelation in the SPSS software. So this was all about data structure and components of data in time series and how to identify them using autocorrelation. In the next video we will discuss about moving average and exponential smoothing techniques of forecasting any time series data. Until then, goodbye and thank you for watching this video.